Okay, so the purpose of talking about the significant digits and stuff is obviously we're going to be talking about measurement. And as we mentioned last class, measurement came out, or 2 classes ago, I guess now, measurement came out of a need to communicate, to discuss how big something is with someone else and to transmit that information over some sort of a distance. And we mentioned when we're talking about length, where we said the unit of an inch comes from the thumb. It's from the end of the thumb out to the point of that first knuckle. That is an inch. So if I wanted to measure the length of this pen here, you go 1, 2, 3, not quite 4 inches. By the way, you notice that motion of measuring, rocking back and forth? You ever hear of an inchworm? That's where it got its name, is because of that motion when it walks, the rocking. You can see how inaccurate that is, though, because I have to, roll my thumb a little bit, and then exactly where does my thumb end? My thumb doesn't have a flat end on it; it's rounded. Exactly where does it end? Does it end here, and I just kind of go straight down, or do I roll it, or what do I do? And every time I move it, I don't mark it and move my thumb. I just look at it and move it visually. So there's a lot of inaccuracies there, and that's where that ruler came from, as being a very handy tool. Now, obviously, an inch is pretty small. If I wanted to measure the height of this wall or the length of the floor of the room here, it would take a long time to measure that using inches. So we used bigger units. Now, of course, the one that we're all familiar with is the foot. The foot is approximately how many inches? 12. Now it's exactly 12 inches, but it used to be approximately 12. And we'll discuss that in a little bit. Well, let's do it right now. It was King Edward, back in about 500 AD, who declared that his thumb was going to be the official inch of the land, and his foot was going to be the official foot of the land. Now, there was not 12 of his thumbs in his foot. What's that? Yeah. But so what they did is they actually cut little blocks of wood or whatever they had for material, and they passed those out to be the inches in the foot. Literally copied it off of King Edward's foot and his thumb. His foot was not 12 of his inches. It was actually a couple hundred years after his death that they decided, hey, if you measure something in inches and I measure it in feet, it would really be nice to be able to convert between them and see if what you measured is the same size as what I measured. And that's when they adjusted the length of the foot and the inch to make it so that it was close to 12. They adjusted them to make it exactly 12. Now, you brought up a hand. Well, where does that come from? Well, yeah. Well, they use it for livestock, yeah. In fact, a foot was used for horizontal distances near the ground. Why? Well, your foot is near the ground. Right now, with modern rulers, tape measures and stuff, if I wanted to measure the height of this wall, I would probably measure it in feet. But back then, when you were using your foot, well, I'd get up to maybe about 3 or 4 feet off the ground, and I'd have to do some serious stretching to get all the way to the top of the wall measuring it with my foot. It's not going to happen. So that's why vertical distances were measured with a hand. Livestock, horses, cattle, sheep are still measured using your hands, which is, now it's approximately 4 inches after they've adjusted it. And what the hand was actually the width of the hand at the base of the fingers, right here, across the palm, the bridge between the palm and the fingers. The hand isn't used anymore. There was also a unit for construction. The foot was actually a little small for construction. It would take a lot of feet to measure things out. Anybody ever hear the unit? Not a rod, a cubit.
Yeah, cubit.
The cubit was from the point of your middle finger to the bend of your elbow, the tip of your elbow. That was a cubit. Now, on most people, that is approximately 16 inches, maybe a little bit more. What's your stud spacing and joist spacing and standard spacings in construction? 16 inches. That was your spacing between studs and stuff when you were doing construction. You've probably heard that term used in a couple of different. The cubit? Yeah? Oh, sure. Just guessing stuff out?
Yeah.
Yeah. The one I use, because it's the one that I know, is the if I spread my hands from the point of my thumb to the tip of my pinky, is almost exactly 9 inches. So I'm pretty accurate that way. So there are units like those that haven't been used. Now, bigger than a foot, we have a yard. 1 yard is how many feet? 3. Anybody know what a yard is? Where a yard came from? A lot of people used to say it's your stride, and your stride is approximately a yard, but a yard actually it's from measuring as a tailor's unit. It's from the center of your chest or the point of your nose to the end of your outstretched arm. That's a yard. So if you've ever gone to a place where a mom and pop fabric store and you order 2 yards of fabric, they'll grab onto it and they'll pull it out 1, then reach back to their chest and grab it again and pull it out 2. That's a yard. Obviously, the tailor with short arms got cheated in fabric.
Is there an name for the one for the wrap from your finger thumb to your elbow? Measuring rope? I know it's one of the things they teach you to Bible courses is how to measure.
Yeah. You know, I'm not sure on that one. I know there's some stuff for navigation. They used to have the marks on the ropes, but I don't know for sure. But so, that was obviously King Edward declared that his, from his fingers to his nose or chest, whatever they were using at that time, was the official yard. And his was not exactly 3 feet, but again, they adjusted it later. Now, there are a lot of units in there. There's, we've mentioned the hand and the cubit. There's also the fathom. A fathom was used for navigation. It's about 6 feet. Well, again, it was a little under 6 feet originally, but they adjusted it to be 6 feet. A fathom was designed to be the height of a person. It actually was the shallowest water that most of your large vessels could navigate through. 1 fathom. So they'd literally have a sailor jump out and plunge into the water, and if it went over his head, they knew they could navigate through it. The league is actually quite different. A league is, I don't remember now. Let's do this. Exactly. I can be modern like any of the kids can. Right? That's always been my favorite, is Ask Jeeves. Here we go. I used to know this one too, and I can't remember anymore. I think it was. Oh, it says it's no longer an official unit anymore.
Really?
Yeah. It was originally meant to be the distance a person could walk in an hour. Most commonly, I knew it was longer than a mile. Most commonly defined as 3 miles. At sea, the 20,000 leagues under the sea or whatever. It's 3 nautical miles, though, not 3 land miles. A nautical mile is just over 6,000 feet, where a land mile is 5,280. 6,000 yards. Oh, no, the league is 6,000 yards. A nautical mile is like 2,000 yards. 2028, I believe, or something like that. 2020. No, 2026 or something like that. Yeah. And of course, there's probably all sorts of other. It's the problem with the standard measurements, like with pounds and stuff like that. There weren't standards across the world. Each country, like the British imperial pound, is different from the European pound and other things. I mean, there's different weights out there. In the metric system, we'll mention the metric system. Our yard, it would make the metric system would be so much more convenient for us if the yard and the meter were the same length. Well, guess what? Yeah, like 3.4 inches, 3.29 inches actually, I think is the exact difference. The metric system was developed in a conference, I believe, in Switzerland, if I'm remembering right. And in Switzerland, the meter that they used is the Swiss yard. But the yard varies from one country to the next because of how it was standardized in different places.
They had it all figured out.
Yeah. It would have been nice to, to have the yard and the meter the same, but.
When was that? When did they break
Believe it or not, most people don't realize the metric system was actually developed in the 1800s. It's over 130 years old now. A lot of people think it was like in the 1970s, but it's been around for quite a while.
That's when they first heard about it.
That's when they first started talking about it in the United States. Yeah. So anyway, we're not going to worry about the fathom or the league or the furlong is 1/8 of a mile. It's only used in horse racing pretty much anymore. But we are going to use a rod. A rod was actually a shepherd's tool. The shepherds had a rod and a staff. The staff was that little Bo Peep type hook. They actually used it. It was designed to be the right size to hook a sheep around the neck, so you could catch it and do whatever, shear it or whatever you needed to do with it. The rod was a protective weapon, literally fighting off wild animals. A rod is defined to be 16.5 feet, or 5.5 yards. Those do actually translate to be the same length. Now think about that, 16.5 feet, that's quite a big stick. But if you're fighting off a wolf with nothing but a stick, you do want a little distance between you and him. To be honest, I'm probably hiding behind one of the sheep swinging at it with the stick. Saying, here, take the scrawny one, yeah. Take this one, take the mangy sheep. But what it really was is they just took a sapling tree, they cut it off, they cut the branches off of it, and that's what they used as a rod. So how did it become a unit of measurement? Well, let's say that you had some sheep and I had some sheep, and they go down into a pasture and they get down in the same pasture. And at the end of the day, we go to take our sheep home, and I say that I had 12 sheep and you say that you had 15 sheep and there's only 20 sheep in the pasture. Obviously, one or both of us is stretching the truth a bit. With cattle, how did they fix this problem? They branded them. Branding with sheep didn't work too well for two reasons. Well, for a few reasons. One, their skin's a little more sensitive. It's hard to brand them. But two, their wool grows out so thick you wouldn't be able to see the brand through the wool anyway. Cattle have short hair. They've actually used to brand horses as well. They have short hair so you can see the brand from quite a ways away. The other reason, and not an insignificant one, wool is slightly flammable. Hit it with a hot brand and poof, roasted mutton. But so they couldn't. What's that? Oh, that was actually a big thing. Is if you were the Circle Bar brand, my brand would be the Circle T. So I just have to brand that little extra line in yours, and now it was my yeah. Yep. But anyway, they didn't have ear tag stuff at that point. So what they did was sheep herding was actually the basis of land ownership and marking off land boundaries. So what they would do is they'd say, okay, we're going to take this landmark, this big rock, and from that big rock, you're going to get this section to put your sheep in, and I'm going to get this section to put my sheep in. Well, then arguments started, well, your section's bigger than mine or whatever. So what they would do is they'd say, okay, from this big rock, I'm going to take my rod and I'm going to lay it on the ground like that. You're going to take yours and lay it end to end, and then I'm going to grab mine and we're going to flip them. And we're going to count. Okay, we're going to go 40 rods this way and 80 rods this way, that's yours. 40 rods this way and 80 rods this way, that's your land. So that we know we have the same size. Now, to this day, if you look at the legal description for your property, it'll say, 26.5 rods, whatever, to the southeast corner. Your land surveying is still done in rods. So that's the main reason why I mention it here is because of that.
What about acres? Is that the survey you would want?
Yeah, we'll get to acres after a while. When we talk about area, we'll talk about acres. Bigger than a rod, we're going to go up to the mile. A mile is how many feet? Anybody tell me? 5,280 feet, or 1,760 yards. Now, there's all sorts of rumors as to where this came from. One of them was it was the distance that King Edward could see out the window of the castle from his throne. The definition that holds the most weight with me is it actually comes from Roman military. You ever hear of a mill rate on your taxes? The mill is a Roman. It's actually a Greek word that also was adopted by the Romans. actually a Latin word, I should say. Mill stands for 1,000, per thousand. Your mill rate is your tax rate per $1,000 of home value. A mile, was 1,000 paces. A pace is if you started on your left foot, went to your right foot, and back to your left foot. It was 1,000 paces of a Roman soldier marching in formation. So they would march for 1,000 paces, and that would be a mile. The average length of a pace was about 5.28 feet, so 1,000 of them was 5,280 feet. And there are all sorts of other units out there, like I said, that we're not going to talk about. The furlong, all that weird stuff. But, those are the basics. If we're going to convert within our standard system, now most of us have done this conversion enough that if we have, 8 feet, and I want to convert it into inches, we know that we're going to do what? Yeah, times 12 makes 96. That's 96 inches. But what really is happening there, when we talked about fractions, if you recall when we had like 3/4, and I wanted to turn it into like 16ths, I multiplied by 4 on bottom, I multiplied by 4 on top. We called this a unity fraction. It has a value of 1. When I multiply by it, it doesn't change the value, but it does change the appearance. It turns it into 12/16. Still has the same value. For measurement conversions, we're going to use a unity fraction as well. It's just going to look a little different. So I'm going to make the 8 feet into a fraction by just putting 8 feet over 1. Now the unity fraction I'm going to use is going to look like this. I'm getting rid of feet, so I'm going to put feet on bottom. And I'm going to inches, so I'm putting inches on top. And my relationship between feet and inches is 1 foot is 12 inches. Now in my fractions, when I multiply fractions, I can cross cancel. I can cross cancel names as well. I can cross cancel the feet. They're gone. Now I've got 8 times 12 inches is 96 inches. 1 times 1 is 1. If I were going the other direction, if I had like 252 inches and I wanted to go into feet, I'd put that over 1. Now my inches go on bottom because they have to cross cancel. My feet on top. 1 foot is 12 inches. So now I would multiply. 252 times 1 is 252. That's just 1 foot, so it's 252 feet. 1 times 12 is 12, and I divide that out to get 21 feet. Make sense? Now, for us, it's probably uncomfortable to do that with feet and inches because we've worked with it enough. We know you multiply or divide by 12. We know how to do it. But if we have something like this, let's say we have 99 feet, and I ask you to convert it into rods. RD is the abbreviation for rods. Most of us have not worked with rods enough that we're really comfortable jumping in and making that conversion. But 99 feet over 1. Feet, rods, 1 rod is 16.5 feet, 16.5 if you would rather do that. Feet cancel out. 99 times 1 rod is 99 rods. 1 times 16.5 is 16.5. Dividing that out gives us 6 rods. And then we jump into the metric system. The metric system is actually what we call a designed system. The standard system of measurement was a developed system. It just kind of happened over time. It evolved. We talked about they started using their feet and their hands and stuff to measure things, to communicate. And we also talked about how it was years later, hundreds of years later, that they finally decided, we're gonna adjust the lengths to make it a system. That's why you have 12 inches in a foot, 3 feet in a yard. Those units were never designed to work together. They forced them to work together later. The metric system was a design system. We had had centuries of working with the standard measuring system and learning what the flaws were and what was good about it, what was bad about it. So then they were able to sit down and design a system of measurement that worked well together. And I know a lot of people dislike the metric system because they're not used to it. But once you get used to it, it actually is a lot more convenient to use. As I mentioned before, you are going to see it used more and more in manufacturing because companies that have international affiliates, it's just so much cheaper. It saves a lot of money not to have to do everything in both units. The scrap rates, design expenses and all that stuff. Millions of dollars a year that companies are finding. I mean, IBM did this several years ago now, and I know the first year they said it was over $10 to $12 million they planned on saving the first year. So anyway, the metric system. The main unit of length in the metric system is the meter. In fact, the only unit of length in the metric system is the meter. We said, well, what about all this other crap we've heard about? Well, yeah, there are prefixes that have been used. It's still a meter. If I want to measure something smaller than a meter, they use the prefix deci. Now, meter is abbreviated with an M. Decimeter is DM. Deci means 1/10. So a decimeter is 1/10 of a meter. Centi means 1/100th. Abbreviated cm, a centimeter is 100th of a meter. Milli means 1/1000th. Abbreviated mm, a millimeter is 1,000th of a meter. Now at that point they stopped going. You can see this one every 10, every power 10, 10s, hundredths, thousands. There is no 10,000th prefix. They skip from thousandth to millionth. And the millionth is micro. No. They call it mu, micrometer. Now in the medical fields, they use MCM for micrometer. The MC is used because the medical fields was one of the first fields that had to key everything into a computer, though there is no mu key on the computer. And rather than having to go into some sort of file and pull out the symbol every time you wanted to type it in, they just did MCM, so they can just type that in as an abbreviation. So micrometer, microliter is used a lot. Microgram is used a lot in the medical fields. They use MCL, MCG, and MCM instead of the mu. But that is the official abbreviation. Smaller than that, at a billionth of a meter would be a nanometer. You've probably heard that word thrown around a lot in the last 10 years. Nanotechnology and all that is nothing more than things that are really, really small. Well, computer chips are going to it a little bit. They're actually talking about nano machines and stuff like that, nano actuators. They haven't found practical uses for them yet because the manufacturing process is just too expensive. You're actually taking individual atoms. You're not taking a piece of material and cutting it down like you are in the standard machining that you guys are working on. You're actually taking individual atoms and placing them in place to put stuff together. And the process of doing that is just very tedious right now. It's not financially efficient. They do it a little bit in drugs, in the pharmacology area, but those are chemically assembled, not mechanically assembled. So it's just mixtures of chemicals that cause them to form in the way they want them to. That's how some of your time-release medications and stuff like that are nanotechnology, nanocapsules, they call them. Going the other direction, if you want something bigger than a meter, deca is 10. A decameter is 10 meters. Now you can see DM is already used for decimeters. So they use either DAM or DKM for decameters. Usually DAM is the most popular one. Bigger than that is hecto. Hecto means 100. So HM is 100 meters or a hectometer. Next is kilo, means 1,000. KM is 1,000 meters, about 0.6 miles. Actually, 0.6. Well, it's 0.625 miles, I believe, the kilometer. 0.624 somewhere in there. Just under 5/8 of a mile. And again, they don't go 10,000 or 100,000. Once they get to 1,000, they skip up to a million. A million meters is a megameter. You notice I actually capitalized the M on mega because the abbreviation is a capital M. So capital M, little m is megameter, a million meters. Realistically, that one doesn't get used much because the circumference of the Earth at the equator is about 25,000 kilometers. So there's really nothing that would ever have to measure 1,000 kilometers or a million meters, unless you're doing astronomical units. Yeah. So, what's that? A click is about a mile. Yeah, yeah. But anyway, they developed all these units at first thinking they'd be useful. And in practice, what became useful was the meter, the milli, the micro, of course, for really small stuff, the kilo, and then the mega, not so much for meters, but when it came to like pounds and liters and stuff like that, mega was more used. Also, if you're a computer aficionado, mega, it was kilobytes, then megabytes, then it was gigabytes, and then terabytes, and so on, going up. In the U.S., not so much in Europe, but in the U.S., the centimeter has become very popular. Can anybody guess why? What are we used to measuring things in? Inches. The centimeter is the closest unit to an inch. So in the United States, the centimeter has gained a lot of popularity because it's closeness to an inch. Realistically, though, in areas that have used the metric system for longer than us, the millimeter is more common for smaller items than a centimeter is. So for the most part, hecto, deca, deci, and centi are not used. Then we talk about our other units like weight and volume and stuff. Those units don't get used except for specialized applications. Like a deciliter gets used for blood testing in the medical fields. If they say your cholesterol is 120, that's 120 milligrams per deciliter of blood and stuff like that is what they're looking at. There are conversions between them. Like I said, a kilometer, your textbook says a kilometer is about 0.6 miles. It's actually like 0.62 something miles, but they're rounding off. 1 meter is about 1.1 yard, or 39.37 inches. And so on. The one that I use, though, because this is the one that's probably the most, all these are pretty rounded. The one that's the most exact is that 1 inch is 2.54 centimeters. That is the one that I use for most of my conversions. For example, let's say that I have something, well, first of all, how do I convert within the metric system? Let's say I have something that is 1.23 centimeters, and I want to convert it into millimeters. To get from centimeters to millimeters, I'm moving one spot to the right. Every spot on here is multiplying or dividing by 10. So moving one spot to the right, the units are getting smaller, so the number has to get larger. When we're doing any conversion, that's something to keep in mind. If the units get larger, the number has to get smaller, or the other way around. So here the unit's getting smaller, the number has to get larger. Basically on the chart, I moved one spot to the right. My decimal has to move one spot to the right. That's 12.3 millimeters. Or if I had 210 centimeters and I wanted to convert into meters, that's going 2 spots to the left to get from centimeters to meters. My decimal point goes 2 spots to the left, 2.1 meters. So let's say I want to convert 10 meters into feet. I could use the fact that 1 meter is like 1.1 yard or whatever. But what works best for me is I'm going to convert meters into centimeters. So 10 meters, 1, 2 to the right, 1, 2 to the right, that is 1,000 centimeters. Then I'm going to convert that into inches. Here's where that unity fraction comes in handy again. I have 1,000 centimeters over 1, 2.54 centimeters, 1 inch. So this is saying, to put it short, 1,000 divided by 2.54. So 393.7. And now I'm just going to convert the 393.7 inches into feet, because I wanted my meters in feet. And of course, I know that to do that, I'm just going to divide by 12. I could use a unity fraction if I wanted to, but we've done this enough. We need to about 32.81, basically. Make sense? Yes, sir.
So, how come you don't just stretch it out into one equation and stretch out?
I could. At this point, I'm not doing that. Just I don't want to. If that's the way you've always done it, just as one big long line, that's great. That's your dimensional analysis. Yep. Yeah. Oh yeah. And that's just fine. That's how I would normally do it too. There are a couple of things we haven't got to yet, but I want to give you a little time to start working on this. I'm actually going to hand out a packet because this isn't, your book doesn't do a really good job of this. So I'll hand that packet out to you right now. It's going to be labeled Unit 19 in the packet, and just do the odds again.